Welcome, Tactical Technician Diagnation here. This is part 2 of our video series, Electronic Noise Diagnosis with Steelman microphones. So basically what we're going to talk about today is the valve train and valve train associated noises. We're going to be on 4 channels. Channel A, orange, is going to be the microphone clipped to the front of the cylinder head in fairly close proximity to the timing chain and the cam phasers. Channel B, purple, is on the back of the cylinder head. The reason I went with 2 microphones, just so we can kind of offset any bias created by a noise in a specific location. We just got that much better look at a possible noise. You don't have to use 2 microphones, 1 will suffice. But since I have the extra channel on the scope, I will complete the scope. There's a 4-channel scope. I'll be using all 4 channels to determine the noise. Channel 3 is a delta sensor in the intake to look at vacuum pulls. Vacuum pulls depict a lot. There's a lot of information we can relate to our microphones because they tell us our transfer points in the valve train, especially when valves open and valves close. We know that valves are open by camshafts that push on lifters, that push on push rods, that pivot rocker arms and push down on valves, and we know valve springs close valves and all the associated components with the valve train, intake and exhaust. Also, bear in mind, a lot of cars today, this car does not have its GDI. Our GDI pumps are driven by camshafts, usually a 2-lobe, a 3-lobe, a 4-lobe, and those things, we all know those things are pretty noisy, and sometimes those can make noises. I eventually may want to get it. You can probably use this methodology if you have a GDI car. If you think you may have a noise that's associated with the GDI pump, you would probably look at put a microphone near the GDI pump, maybe put another microphone on the other end of the head, and you know that those the noises coming out of that GDI pump will definitely be in sync with the PCM command to the fuel volume solenoid on the GDI pump. So basically, I don't want to turn this into a GDI class, but there's definitely a electronic acoustic relationship. But nonetheless, that's where we stand. I will show you the scope, and then I'm just going to do a little bit of I will start the car and let it idle, and we'll talk about what's going on. Hope this thing will hang in there. Okay. 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 Sorry for that delay. My bad. Okay. All right. We know we got. Okay. I'm going to start the car. We'll talk about the signals. Talk to you about scope settings. We got about 1 volt on purple, 1 volt on orange. We want to keep those the same amplitude. Our time base is 200 milliseconds. Our vacuum transducer, I'm going to get down to 5 volts. We got to get more granularity on that. And of course, our trigger right here, our ignition trigger is our reference point to determine where the engine is in its crank cycle, to see what stroke it's on and things like that. So let me just do a little tap test. I'm going to tap on the center, dead center on the cylinder head, and watch the orange and the purple channels. Okay. Well, one microphone had a little bit of a bias. It could be there's a variable associated with that, just because we have so much different things making noise. I will tap the front of the cylinder head. Orange had a little more orange. The orange clip is closer to the noise. Obviously, that makes sense. That signal had more amplitude. I'm back on the back of the head now, and you see our purple signal had more amplitude. That's just a way of offsetting if we were diagnosing a valve train noise, we got that much more, I don't know what's the word, reconnaissance on the cylinder head to know where the specific location of the noise is. But anyway, I will stop the engine and we'll kind of talk about the events, and then I'm going to do it cranking, just so we can kind of slow things down and get an idea of the valve train events. We'll shut it off. Okay, I'll stop the scope and we'll roll it back and talk about it. I'll take one channel at a time. Let's get a little more vertical zoom on pink. Those are our vacuum pulls. I will pull them up and I'll kind of zoom in on it, and we'll just talk about a fire cycle. And we want to concentrate obviously on our microphones. That's what they're the reasons why we're here, to diagnose the noise. And we don't have an abnormal engine noise. You can see, as I mentioned earlier in the previous video, we usually see 4 normal events in a fire cycle, because we know there are 4 combustion events. But see the relationship? It's between the 2 microphones on the on top of the cylinder head. This is TDC for cylinder 1. Let me kind of zoom in on even better. And now we got a good picture of everything. And let me get some partitions in here. It's a 4-cylinder, so I want to get 4 rulers in and just talk about the relationship. Oh, I think I overdid it there. Did I? Oh no. Did something wrong. Do I know how to use my scope? I guess I get in a little bit of the malaise. All right. Maybe I gotta do this. That's right, I know. There we go. See, little faux. I see. I jumped the gun there, but now I gotta get my. Do I have 5 rulers? I want to make sure I have 4. Okay, I got 4 rulers now. That's what I wanted. I know this is 1. 1 is at TDC here. The combustion process starts. I mean, it gets its spark here. This is the trigger to the number 1 coil, and it descends on its power stroke. Its exhaust valve opens about right here. So we know that when an exhaust valve opens, we have a cam lobe that's going to move a lifter or a push rod or pivot or rocker arm, push down on a valve. And the variables associated with that, we got to realize different specific technologies. Vehicles have VTEC, variable valve lift, active cylinder management comes into play. So we got to know what we're working on. So basically, we're just concentrating on our noise. We don't see any we won't see any abnormal noise in this video. But nonetheless, if we have an actual car with a noise, we can use this technique to key in on the noise and use our other channels as source validators to see where the noise is coming from. But anyway, its exhaust valve opens here, and then it has its exhaust stroke. And in this area right here, it's the overlap area, the exhaust valve closes about right here, intake valve opens about right here. So we know what's associated with that. We have cam lobes moving, opening valves, and we have cam lobes descending, kind of closing valves, and valve springs closing due to the valves closing due to the valve spring. Right here, we about 50 to 55 degrees after bottom dead center is when the intake valve would be closing. So we know that cam lobe is coming down, and the valve spring is going to close that intake valve, and then we do the cycle again. But see, with this kind of technique, and there are overlays. I didn't use one here, but an overlay would be that much better, because then you get to see everything, and you'll be able to look at what cylinders on what stroke. There's a freebie online called a waveform overlay, and there's one called Drivability, guys. It's $20. It's got great coloring. I bought it. It's the colors on the freebie aren't as vibrant as the $20 one, but it's your free will to decide what you want to do. But an overlay would be phenomenal in this technique here, knowing what cylinders are on what strokes. Okay, I will turn the scope back on. I just want to do this cranking just to see, because to slow things down. I'm going to shut the fuel down and then do everything cranking, and then we'll kind of reanalyze. I'll just give you a scope picture of what it looks like when it's cranking. Make sure what you saw there, you probably saw something there, which was interesting. I guess I'll see it later when I watch the video, but I'll stop I'm going to start it now, and I want to get a little bit of, I know to go to 10 volts here so it doesn't hog up the screen like you probably saw it do, but nonetheless, here we go. Let me turn this thing a little bit to the right, keep the symmetry good. Symmetry is important. stop the scope and we'll analyze. Okay, need some more vertical zoom. Less vertical zoom. We can bring the pink guy down. Okay, here is our shot. Okay, basically this is cranking. Things a lot slower. I just wanted to do this also. You know, just both ways. Basically same situation again. We got our vacuum pulls denoting what cylinder is on its intake stroke. We can deduce a lot from the, you know, 720 degrees between here and here. You set up the rulers, you set up your overlay. Obviously, we're looking closely at our microphones, and this, we're going to deem this good. This car does not have any noises that are abnormal, like a broken valve spring, a valve issue, anything valve train related. So just something to bear in mind. I'll be coming back with some more videos where we're going to actually see timed noises related to the engine. Thank you very much.